Good morning and welcome. My name is Clay Carper, and I am here to talk to you about the Kraken-funded summer camp where we taught middle schoolers about blockchain concepts. So, effectively, what we built this camp around was the idea that we wanted to teach students about modern complex ideas while still being able to approach the crowd that we had. In this case, it was middle school age students. So, um, our goal then was to not make this feel like a school session. So to help kind of facilitate that, we primarily developed game-based learning. Now, this was a mix of kind of individual activities, so like things like puzzles, like crosswords, or like kinetic puzzles, like metal puzzles, like stuff like that. Just a good range of activities to kind of give different skill sets different things. So we had mathematical things, we had writing things, we had reading-based things. So we kind of just tried to hit as many things as we could to still give students some sort of structure to then say like, oh, by solving these games, you're earning a point or whatever it might have been in that context to help encourage them like, oh, I'm doing work and I'm getting something out of it to kind of emulate some of those blockchain concepts. So some of the other types of stuff that we did things like Caesar ciphers. So we had wheels that we had printed that students could physically like manipulate to see like, oh, if I have a mapping between like A and L, then the rest of the letters have that correspondence, and they could physically see like how that rotational action of that cipher actually works in physical space, which is really cool. Again, we really tried to emphasize a like very minimal amount of mathematical skills, especially because students tend to be very stressed about using those concepts. So rather than putting a strain on it and saying like, oh yeah, you don't understand this, because we had a range of middle school age students, we couldn't really leverage on that too much. So we really tried to keep it math light to really include as many students and not make them feel like, oh, I don't enjoy mathematics, or oh, I'm not very good at mathematics yet, so I'm not going to be good at this camp. We also measured students' knowledge before and after the camp to try to get a snapshot of how effective were the activities. And based on the preliminary data analysis, we at least have some evidence to be able to say like, yes, the way that we taught things and the way that the students interacted, they were able to gain more knowledge of the underlying concepts, which is really cool. So to highlight some of the kind of different things that we did, so again, we did a Caesar cipher-based battleship game. So traditionally, this game is played with two different boards where each person sees where their ships are, and then they try to find the opponents without knowledge of where they are. We used a variation of this where we had them play with a single board, in this case being a whiteboard. So the students had to encrypt the position of their ships, keep track of where their ships were, and tried to figure out the encryption scheme of the other team based on what they could see from that shared information. We did a consensus-based voting activity with microbits where each student had one, and basically for the team to be able to answer the given question, all of them had to agree on the answer, and they all had to set their microbit to the same value. Going off of that, we also taught the students a little bit about trust and like, hey, what happens if everybody's not doing what they say they're doing, right? So we really tried to kind of tie in some of those ideas. For the work, again, as I mentioned previously, primarily we encourage them to solve problems or puzzles, just something to get them to do an activity to get something out of it, to kind of show like, hey, in this space you do work and you get a reward for it, okay? We also had them build out paper-based blockchains, which most of them were like the old like paper chain style strings, right? So just getting them to think about this idea of like, all right, how do I link this together? What's special about the first block? Like, should it be circular? Should it not? Just kind of getting them to think about some of these ideas. And then finally, the last activity that we did was this blockchain murder mystery. And what this was basically we had like given them a framework of saying like, hey, there's been a murder. This is how you can step through and figure out who did it. And they basically did like similar activities of what they had done previously throughout the week to kind of put all the pieces and all these concepts together to ultimately get an answer to find out who had done it. So thank you for joining me, and have a good one.